ओके जी, वेलकम बैक। Can you hear me now? आवाज आ रही है जी? ओके जी, वेलकम बैक। कैन यू हेयर मी?
Yeah,
आवाज आ रही है जी?
जी
yes,
सर,
sir.
आवाज आ रही है।
Yes, sir.
Okay जी। So let's start again. So before that, we were discussing the output characteristic curve, and in the output characteristic curve, we have seen that basically we have the active region. In the active region, we have the emitter based junction need to be forward biased and the collector based junction need to be reverse biased. And where in the active region we have the normal operation of the transistor. Then if we make the collector based junction forward bias and the emitter based junction is also forward bias, then we go into the saturation region, right? And if the emitter based junction is no more forward bias, so this means it will become reverse bias. So collector based junction and emitter based junction both are reverse bias. That region is basically taken as the cutoff region. Okay, so these are the three regions of operation of the transistor. Okay, now if we see that there is a term which is called alpha, and alpha is basically the ratio of that component of the currents which are due to the majority carriers, and it is basically the component of the the collector current to the emitter current which is due to the majority carriers. So it is basically a ratio of the collector current to the emitter current for the majority carriers, right? Because anyway emitter is the current due to the majority carriers, collector is having, if you remember, collector is having two portions. One is the component due to the majority carriers, one is the component due to the minority carriers. And we have said that IC is equal to IC majority plus IC minority, and which IC minority we replaced the IC minority by IC, we replaced it by ICBO, and ICBO is basically the collector current which is flowing through the collector base junction when the emitter is open. And if we replace this IC majority by this, So how this will look like, IC is equal to alpha times IE plus ICBO, right? Are you with me?
Yes, sir.
Right. So
Yes, sir.
alpha is basically the ratio of the collector current to the emitter current for the majority carriers, right? But we also know this thing that the component due to the minority is very very small because it is in the range of microamperes, right?
Milliampere, microampere.
ICBO is in the terms of microamperes, and IC majority is actually in the terms of milliamperes, right? So the milliamperes is comparatively to microamperes is a bigger number. So the overall impact of the ICBO is very very small. So therefore, we normally when we normally write alpha is equal to IC by IE, because the impact of ICBO is very very small, right? So so this is alpha, which is normally called the amplification factor for the circuit which we have seen up till now. Okay, now if you see this kind of a circuit which we have just discussed, the circuit which we have just discussed over here, and in this circuit we said that we have the input side as well as the output side. So this we said this is the input side, and so in this circuit we have the input side as well as the output side. So if you see in this circuit we have the emitter based junction is on the input side and collector based junction is on the output side. So if you see, the base is common in between input side as well as the output side. So such kind of configuration of the transistor in which base is common in between the input and output side, that kind of configuration for the transistor is called common base configuration, right? Common base configuration, and in short it can be written as CB configuration, right? It is written as CB configuration, which stands for that common base configuration. Common base configuration means that the base is common in between input and output side. Similarly, we have another configuration in which we will have a circuit in which we have common emitter configuration, right? So common emitter configuration means the emitter will be common in between the input side as well as the output side. And similarly, we have a third configuration that is called common common collector configuration, right? Common collector configuration. So For a transistor, normally we have three major kinds of configuration. One is called the first one, that is called the common base configuration. Then we have the common emitter configuration, and then we have the common collector configuration, right? And these configurations can be for NPN transistor as well as they can be for PNP transistor. The operation is same, but only the directions of the current, they will be opposite from one another, right? As well as the direction of the polarities will also change, right? So that's it for today. Any question up till now? Any
सर
question?
ये VCB और VCC सेम होंगे?
G?
VCB and VCC, voltage across output,
Okay, if
ये
we
दोनों सेम होंगे?
hold on, if you see in the circuit or here, if you see, you can apply KVL over here, right? When you apply KVL, what you are going to get, you will get the equation VCC is equal to IC RC plus VCB, right? Are you with me? So
सर अगर रेजिस्टर ना हो,
अगर रेजिस्टर ना हो तो जाहिर बात है VCB will be equal to VCC, right? But to limit the flow of current in the outer circuit, we need to have a resistor in the circuit, right? So then you are well aware that VCC will always be greater than VCB. But if there is no resistor in the circuit, that will be again just to make you people understand. But there is always a resistor in the circuit so that you can limit the flow of the current, right? In that specific case, the biasing voltage will always be greater than the uh, potential which will develop across the collector base junction. Is this thing clear now?
yes sir.
Right? Okay.
Excuse me, sir.
GG question.
Sir, the transistor active or passive component, sir?
What you can see, transistor is active or passive?
Yes, sir.
G. Transistor is
सर
active.
मैं कह रहा हूँ कि yes sir, I think एक्टिव है क्योंकि इसमें तो हमारे पास एम्प्लीफिकेशन प्रॉपर्टी है सर ना.
बिल्कुल. ठीक है जी. Okay, so that's it for today, and thank you, and see you next week. And one more thing, the midterm exam, the schedule is here. It will be not the coming week, but after that week. So it will start from 29th of June.
तो सर ये कोर्स अभी तक जो हमने पढ़ा है वो मिड टर्म में आएगा, यानी जो नेक्स्ट वीक भी हम पढ़ेंगे वो भी मिड में शामिल होगा?
जी, वो जो नेक्स्ट वीक पढ़ेंगे वो भी आएगा.
ओके
जी.
अस्सलाम वालेकुम
सर क्विज में थोड़ा मस्त है सर.
जस्ट होल्ड ऑन.
सर ये क्लास गूगल मीट पे लिया करें.